Hello, my name is Samuel Gonzalez and I'm working with Antonio and Regan and we're going to study chemical reaction, which is our lab number 5. The background of this experiment concerns about when a chemical reaction occurs, substances called reactants and transformed into different substances called results or products that might have different appearance and different properties. There exist two kinds of reactions. These are exchange reactions and displacement reactions. The exchange reactions are those reactions that when two ionic compounds are reacted together in aqueous solution. And the resulting products reflect an exchange on the anions and cations. If a solid is formed, is what we call a precipitate. The displacement reactions are the type of chemical reaction in which an element in its pure form displaces a different element from a compound in aqueous solution. The objective for this experiment were determine the solubility rules for cations and anions by carrying out a series of chemical reactions and observing those changes that can take. Also, we have as a objective how copper, zinc, magnesium, and hydrogen react to metallic salts and hydrogen acid solutions. For part A, we picked two compounds and react them together in our aqueous solution. The result, we first mix KOH and CnSO4 and it's from a precipitate on the mixture. In the part A for this experiment, we picked two compounds and we react them together into a aqueous solution. We mixed potassium hydroxide and zinc sulfate. That's what the compounds that we chose, and they formed a precipitate on the mixture.
Part B was determining the relative reactiveness of elements. The objective here was to determine the relative reactives of copper, zinc, magnesium, and hydrogen by reacting the metals with solutions of the metallic salts and hydrochloric acid. The aqueous solutions in the compound were copper sulfate, zinc sulfate, magnesium sulfate, and hydrogen sulfate. The metallic elements were copper, zinc, and magnesium. To determine if a chemical reaction occurred, you need to observe the reaction. If the color of the solution or mixture changed, whether if it was cloudy, and whether bubbles were detected, so formation of a gas, or if a participant formed, then you knew that a chemical reaction had taken place.
In this part, we're gonna react magnesium with hydrochloric acid in a solution. First, we need to transfer a 0.5 centimeter of magnesium ribbon to the bottom of a clean test tube. Then, we have to add 2 milliliters of 0.1 molarity HCl solution in a 10 milliliters graduate cylinder. After this, a chemical reaction is going to occur.
In this reaction, we observed that when we mix the solution, there was a color change from bright yellow to dark yellow.
In part 2, we're going to react lead nitrate with potassium iodine in a solution. First, we need to transfer 10 drops of 0.1 molarity lead nitrate. And then we have to add 2 drops of 0.1 molarity potassium iodine. After this, we're gonna see a reaction which is gonna occur in the test tube.
In this reaction, we observe that when we mix the solution, there was a color change from bright yellow to dark yellow.
In this section, we're gonna react hydrochloric acid with sodium hydroxide. First, we have to measure 2 milliliters of 0.1 molarity sodium hydroxide using a 10 milliliters graduate cylinder. Then we have to put the sodium hydroxide into a test tube. After this, we have to add 1 drop of phenolphthalein into the solution that contains sodium hydroxide. After this process, we have to measure 3 milliliters of 0.1 molarity of HCl. We have to measure this amount using the 10 milliliters graduate cylinder. After we finish this step, we need to keep going to the other step, which is add 1 drop of phenolphthalein into the solution that contains hydrochloric acid.
In this reaction, we observe that when we mix the solution, there was a color change from bright yellow to dark yellow.
Fully pour 1 milliliter of HCl solution from the graduate cylinder into the test tube containing the sodium hydroxide solution. The remaining 2 milliliters of HCl solution from the graduate cylinder until you see a color change in the solution. Then rinse the test tube twice with 5 milliliters of tap water each time. We're going to react chloride iron solution with sodium hydroxide solution. First, we have to obtain 1 milliliter of 0.1 molarity iron chloride solution. We have to get this solution using the Rhines 10 milliliter graduate cylinder, and then transfer the solution into a clean test tube. Then the next step is transfer the 1 milliliter of 0.1 molarity sodium hydroxide solution into the Rhines 10 milliliters graduate cylinder. The next step that we have to follow is transfer the sodium hydroxide solution from the graduate cylinder into the test tube containing the iron chloride solution. Then we will see a reaction.
In this reaction, we observe that when we mix the solution, there was a color change from bright yellow to dark yellow.
This experiment was very time-consuming because it mixed many different solids with many different compounds. But the experiment was very successful at demonstrating how some solutions could be highly reactive and others not, depending on once they were mixed. This experiment also showed how different chemical changes such as color change, participant formation, and formation of a gas. This experiment concluded with the observations being compared with the theory, and some reactions didn't have any chemical change at all, which was expected.